Okay, so welcome back to Alkenes and Alkynes. We're going to go a little bit more into some examples here. And we're going to deal with what happens when we have a double bond. Or sorry, two double bonds. And so in this example, when we box the parent chain, here is the longest continuous carbon chain with the inclusion of some of the double bonds here. Anything outside, as previously mentioned, is going to be a branch. So now when we're naming these, again, we're first going to prioritize the position of the double bonds. If they're both the same, which in this case they both are the same distance, the left side and the right side are equally close to the first double bond, then we're going to see which side is closest to the first branch, which would then be this side over here. And so we're going to number this way. It'll be 1, 2, 3, 4, 5, 6. Okay, this here would be a 2-methyl, and this would be a 4-ethyl. And as we previously have done, we will organize these in alphabetical order, which means that the ethyl will be listed before the methyl, and we'll name this molecule as follows. Before ethyl, 2-methyl, hex 1. So the bond occurs from 1 to 2. Remember, we always take the lower number, 1, and from 5 to 6, 5. So 1, 5, hex 1, 5, diene. Some of the textbook answers and some of the worksheets might write an A in front of here for adene. It really just depends on the prof's preference. For me, I just write diene, but if you see adene over here, that's fine as well on a sheet. Don't panic. Right, the last example that we're going to do for alkenes is going to introduce kind of a new concept. So our parent chain would be as follows. It would be the longest continuous carbon chain, grabbing, of course, all the double bonds, and all the branches would be circled. Now, this branch in particular here, and I'll circle this in purple, is an unusual branch because it is not an organic branch or a carbon holding branch. It has a halogen. And so we're going to write halogen, question mark. And underneath this, we're going to write another little rule here. And so the rule is that in some cases, halogens attach themselves much like a branch, which means we're going to treat them similarly. And by treat them similarly, we mean that for starters, we're going to label the carbon number they occur at. So that fluoride, we are going to talk about what carbon that is bonded to. And secondly, we place them in alphabetical order. Okay, so I'll just write alpha dot order, so alphabetical order. And we place them in alphabetical order with the other branches. Okay, so we place them in alphabetical order with the other branches. And by halogens, what we're talking about more specifically here is if we go to our periodic table, it's this last group all the way down to iodide over here. And so whenever these attach themselves as branches, they're named accordingly. So fluoride is going to be called fluoro. Okay, let me see if I could make that a different color so it stands out a little bit more. Give me a second here. Yeah, we'll do it in pink. So fluoro. Okay, this one would be chloro, bromine, it would be bromo, and of course iodine would be iodo. And so going back to our molecule, what we're going to do is we're going to label and label each carbon as we normally would, start counting from the side that's closest to the double bond. In this case, there's two of them. So we're going to start then to the one that is closest to the first branch. which in this case, this side has a branch that has two branches that start in the third carbon. We'll start here. 2, 3, 4, 5, 6, 7. Okay. These two are methyls, and we'll use the appropriate prefixes. And this is a fluoro. And this, more specifically, is going to be a 3-fluoro. So when we put all of this together with the methyls and all, our final answer ends up being this. 3-fluoro dash 3,4-dimethyl. And then looking at the parent chain, there are 7 carbons. There are 2 double bonds. So we'll go from 1 to 2 and 6 to 7. So it'll be hept 1, 6 heptadine or heptadiene. And again, like I said, in some cases, they'll put the A over here as well. But we're not too picky about that. So this is the full name of the compound above. So the last type of hydrocarbons that we're going to look at here in this course are what we call alkynes. And so they're hydrocarbons with at least one triple bond, and they are unsaturated like alkenes because, again, they have even less hydrogen than alkenes, but ultimately they have less hydrogen than alkanes, and anything that loses hydrogens becomes unsaturated. Now, just like the alkenes, their suffix depends on how many triple bonds there are. If there's one triple bond, then of course it'll just be -ine. If there are 2 triple bonds, it'll be diene. And I put an A here because some answer keys and professors like to put an A in front. And then same, if there are 3 triple bonds, it'll be atriene or triene. Otherwise, what they're going to do is they're going to obey all the same branch rules. You're going to begin counting from the side that is closest to the first triple bond. And if both sides are equally close, then you count from the first branch. And so the only difference really is the suffix. So for the first example here, we're going to identify the parent chain, and the longest continuous carbon chain would be this one over here. We're going to begin by counting from the side that is closest to the first triple bond, which would be this side over here. So it would be 1, 2, 3, 4, 5. The branches are the things that stick out, and both of these would be methyls. And just like in previous questions, we're going to state the methyls beforehand and then label the parent chain. And just like the alkenes, you have to identify where that triple bond occurs at. In this case, it occurs from 1 to 2. So putting it all together looks like this. We have 4 dimethyl. Pent, since there are 5 carbons of the parent chain, pent 1-1-ine. And so the final name here is 4,4-dimethyl pent-1-ine. Looking at the next example here, again, we're going to identify the parent chain first. And so we'll go, here is the longest, most continuous parent chain that grabs all the triple bonds. And they're both equally close. There are 2 sets of triple bonds here. They're both equally close to the first triple bond, but this side here is closest to the first branch. Okay, the bromos over here. So we're going to begin counting here, which is 1, 2, 3, 4, 5, 6, 7. And like everything else, we're going to circle the branches so that we know what they're called. This is an ethyl, and these 2 are bromos. And putting it all together, we're going to name the branches first, and we're going to name them in alphabetical order. The bromos come before the ethyl, so it'll be 3,3-dibromo bromo dash 4 ethyl, and then it's up to 7, and the first triple bond occurs from 1 to 2, and the second triple bond occurs from 6 to 7. So we're going to write hept dash 1 comma 6. We always take the lower number from each. 6, and then it's going to be diene or adiene according to some, but the key word there is diide. And this concludes alkenes, alkanes, and alkynes.